But you can, if you say it to somebody, they're going to know what you mean, so don't sweat that. But yeah, you want to have classes that have related objects and related behaviors within them. And so if I'm talking about a person, I want to have like a cattail in my class that's going to make sense. If we're talking about boats, we don't want wheels, right? Boats don't have wheels. So we need to have it related. How big should a class be? And what was the max length of a class? Is there a max?
That's a good question.
No. Not new languages. It's not an actual theoretical max. But how big should they be? Ties into today. What do you think?
I don't know. I never thought about how big a class should be.
It should be the minimum amount to get everything done.
Okay.
Nothing more than what you need.
That's good. That's good. There's a book called Clean Code by Uncle Bob. If you don't know Uncle Bob, look him up. Robert C. Martin. It's really, really good. He's got a lot of books that are just imperative to your career. So check those out. They're good. But he'll tell you, it was back in the day, I think his was 40 lines or 70 lines, which is kind of unreasonable now because we have like so much vertical spacing in our files now that's not enough. So, somewhere in the 120, 150, 200 range. If you have a 1,000-line class, it's too big. Why is it too big? Why is it too much to have 1,000 lines in a class?
I feel like it gets pretty hard to manage once one class is that many lines. Just like managing all your methods and what's going on in each method.
It's good.
I feel like the classic answer is scalability.
Yeah.
I feel like it's always the issue. Once
Yes.
you gotta start getting bigger, just things just don't work.
Don't scale. So as you add behavior to that class, it's growing, it's getting larger, but it's getting more and more complex. So that you can't scale your product that way. So if you're trying to add just a bunch of static behavior to a big class, you're going to just continue to grow that class over and over and over. So today, as we talk about polymorphism, keep some of that stuff in mind, because you're going to get to see why you can have something that just have a bunch of like a switch case. You guys know switch cases, or if-else conditions, where there's a bunch of different ways to do something, and there's lots of branching. And when you get into like test-driven development and you're automating the certification of your software, there's something called branch coverage with your testing tools, and it says how well have you covered every branch of your software. And so some of us were talking the other day, TimeClock Plus has two parts to it. There's the front end, which is AngularJS, and then there's a back end, which is .NET, right? Matthew, you're having trouble remembering that. So it's .NET on the back end. So just the back end is 2.7 million lines of source code, okay? And that was started in 2015. So it's not like, we've been out for 30-something years, but we wrote it from scratch starting in 2015. So that's a lot of source code. It's a ton. So trying to manage that with these large classes would be impossible. You couldn't scale. So you have to be very careful. You're going to find situations realistically, empirically, when you start working, where you've got a class that's like 800 lines, and you're like, gosh, that one. I got to go change that class. And it's like, you don't want to do it. Those are normally factory classes, so it's another design pattern. The other thing to mention is we've got the computer. What you're going to learn is normally probably 40-50% of your job is on the whiteboard, and very little of it is actually sitting down and writing the software. So just get used to it and understand that. So normally I would have shown you guys on a whiteboard first, but we're just going to jump in. Okay. So does everybody have Visual Studio open? If you don't, go ahead and get that started.
Which project do you want us to use?
So I just did, I think I did a .NET console application, or .NET Core console application.
The first one, all right.
Is this C++ or C?
I think it's C#, right?
Yeah.
C#.
So let's just right click on your project. So does everybody know the layout of what we're looking at here? So this piece right here, this is called the Solution Explorer. That's where all your source code is going to be. This thing here at the bottom is the properties for elements that you're dealing with right now. So we don't care about that. That's typically, if you're going to write a WinForms application or something with graphical elements, you'll select an elephant in the graphical designer, and it will give you all the attributes over for that element. So we're not going to use that today, so I'm just going to close it and get out of my way. Okay, so the next thing is we're just going to create a folder. So right click on your project and add a new folder. And so called source. And I'm going to look like a buffoon because I'm a Vim person and I don't have it here. So I'm going to look like I've never typed in my life. And that's okay, judge me all you want. Okay, y'all ready? Y'all have that?
I hope so.
I hope so. Y'all stop me if y'all need me to stop me, okay?
No, we're going good.
Okay. So the first thing we're going to do is add, let me see how to show this. Let's add a class called cat. Good?
Mm-hmm.
Okay. So normally the first thing we would do is we'd adjust the namespace, the modifier, the accessibility of the class. It's not that important here. We're just going to keep one project. So all that's not nearly as important. So let's skip all the extra steps and just go right into it. So what's an attribute of a class? I mean of a cat. Sorry. Okay. So let's say bool has tail.
Wow, that's also. Can we? Is there any way on the view to make the text bigger?
Yes, I think we just control.
Oh, thank you.
Sure. Okay. So public bool has tail. Do y'all know what properties are yet? Have y'all done Java? So fields or C++, we have fields in the header file that you also put and use in your CPP file. So it's just like a public string something or public int something or private int something. So what we're going to do is a public bool has tail. And C#, one of the reasons it got popular is these little guys, these getters and setters. Okay? We're going to use those today. So don't worry so much about the get set piece. I'm not here to teach .NET or C# or anything like that. We need to focus on the concept, right? So some of this stuff, don't get bogged down. So we're just going to create something called hasTail. And so now it's a member property of cat. So if I say cat.hasTail, it can be true or false. Makes sense, right? All right, let's save that. Let's pop over to our program and let's use it. How do I use this?
You got to include it, right?
Yeah?
Okay, so you would need, does C# have, is it like C++ where you use include, or is it?
Same concept. What's our namespace? Do you guys remember? Everybody's might be slightly different. Whatever you named your project.src.
The SRC is the name of your folder, right?
Yeah. Yeah, and normally we'd clean that up and not have the .src suffix. I just don't want to confuse things today. I want you to focus on the right things today. Okay, we doing okay? Anybody stuck? Okay. All right, so how do I use it now? Now that I've got it included so I can reference it, how do I create an instance of that object?
Well, I've never done C#, but if it's anything like C++,
Yep.
you would create an object of the cat
Okay,
class.
good. That's perfect. I would say create an instance of the cat class, and that becomes an object. So, good. Anybody know how to do that in .NET or C#? Let me just show you. So we have our cat. What's our variable name in that on that line? Go right in.
That's funny. Can't go wrong there. Which one?
I wanted somebody to get it wrong. It's like, come on,
So there's only 4 of them.
dog.
It's lizard.
Yeah.
It's lizard. It's equals.
So which one's our variable? Let me. You might know. Yeah. Good. So what we're going to do is all of our locals. So our local variables, we're going to use lowercase letters to start them off. Anything public or member variables are going to start with an uppercase letter. Okay. That's super useful when you get into having thousands of classes or 50,000 classes and you're in a method looking at things that are starting with a capital letter or a lowercase letter. You know it's scoping immediately. Helps a ton. Okay, so what can I use on cat? Get instead of what? Has tail.
It's going to default to not having a tail, right?
Okay.
What's up?
No, okay.
Good?
Yeah.
All right, let's create a new class.
Fish.
I also realized that I should be capitalizing these classes.
Yeah.
That earlier I had all lowercase cat equal new cat.
Yeah.
All lowercase.
Yeah.
So I changed it real quick.
Okay, cool.
But just something to point out. I was like, dang. Okay.
And guys, depending on what language you're in, all this can change. So if you're writing in Pi, you're likely not going to start it off with uppercase letters. If you're using Ruby, it's going to be slightly different. Java is going to be slightly. So all of it's going to depend on language-specific things. What I would encourage you to do is all the languages that you learn, follow the language patterns, not your own. Don't force the language into what you do. Adapt to the language. It's super stressful to go into a language that somebody's written something in and they were a .NET developer and it's all .NET conventions. Because if it's in Ruby or Pi and somebody comes in and writes in that same language that's an expert in that language, they're like, what the heck's going on? Why does it look like this? Well, some .NET developer wrote it. Good example, my brother, they know. My oldest brother is also a developer. He's an architect. And back in 2006 timeframe, there was a technology called, it was Xamarin, kind of the way you know it today, but that's morphed into a new version of Xamarin. But to write an application for an Android device, he wrote it with .NET and then rooted his phone, installed the .NET runtime on the phone, and that's what he did for mobile development. I was like, Marshall, just learn to write Java. It was just a lot simpler, man. Come on. He would not do it. To this day, he is 40 years old, just had his 40th birthday. He can write in one language. One language. That's nuts. So don't do that. Yeah, you got to not do that. Okay. So notice we don't have any members at all on fish. Okay, we've just got a fish. So if I go back to the program and I create an instance of this, had to change it up since you guys gave me a heck last time. So now we've got fishy. What do I have on fishy? Are there any members on there? Okay, so what can we do with fishy? Nothing. Okay? We can't do any of our stuff because we don't have anything on there. So by default in .NET, you're going to get some stuff built into object on its own, like toString, hash code. It's fishy. My bad. So equals hash code type toString. Okay, those are a few things that are just going to come on every single object type in all of .NET. Okay? You can override those and change the default behaviors, but they're always there. So I want to be able to say has tail with this. I already have cat, and we know the cat's defined by having a tail. I want to be able to do that with the fish, right? But I can't So if I say it has tail,
I don't have it. What do I have to do?
Write the same thing.
Right, what? Dude, no pronouns. Give me specifics. Tell me where to go.
You have to go back to the fish
Good.
and create that function inside of fish.
Not a function.
The
in
member variable.
Good.
Thank
So here we go. Ready?
Words are fun. Words are fun.
Now, when you look back at program, the program will have the ability to set a property or a member variable called has tail. Okay. Where are we going with this?
Well, that means for every, I guess, animal that you have to write in has tail. Like
Yeah. Okay. So I want to do something real quick. So we're going to write a method down here at the bottom called get animal, and I'm sure this is how all your programs are looking right now in school, where you've got an int and you're doing a switch case or an if-else condition, and it's probably really difficult. Logic can't do those. So animal type equals 1, else if animal type equals 2. I'm intentionally going slow, so if I get too fast, tell me.
Wait, you're going slow?
Yeah.
Oh my god. So why are we putting this as 1 and 2? Are like we're getting something to like do a name or number maybe?
Sort of. So what I want to show you guys here in a moment is that we got to tile this together somehow. So what we've done is we've created one class, we put a member variable on it. We created a second class and realized it doesn't conform to they're both animals. They both could set has tail, but we had to go add the has tail thing to the second one. It's like, okay, fine, we'll do that. But we're going to see here in a moment is there's a smarter way to do it, and that's going to tie all this together. And you'll see how the software can scale if you use something like polymorphism to help you have levels of indirection. So you're not always just brute forcing everything that you do. Okay? So is everybody caught up? Hope y'all are paying attention. If y'all are not getting it and you're not saying something, I'll come across this table. I'll do it. Okay, we're good? Okay. So what types can I return out of this method right here? What data types can I return?
Cats.
What about fish?
I mean, your private method says it has to return a cat, doesn't it?
It does. Very good. So what happens if I try to return, let's say that animal type 1, let's do the old school thing. Say this is cat.
Fish. Don't use magic numbers. Don't use them. We're using them. Brevity. We're going to pull this out.
Okay.
Okay, so I'm saying, look, up here in our program here in a moment, we're going to call get animal. Okay? Whoa. We'll do something like this. We're going to say get animal. An animal can get returned, but we know, as Ignacio said, we can only return one type of animal. But for fish, what if I wanted to return a fish here? How do I do it?
Ah. So I don't think I'm going to increase the size of the IntelliSense. So what do we do? A class that holds both?
Yeah.
Okay.
Just make like a class of animals. more efficient side of it.
Okay. So everybody don't do this. Just watch for a second. Whoa. So I have caps lock is remapped to escape. So I hit caps lock the whole time and I'm in caps lock. Okay. So I can do that, right? So I can say cat. Also, I use a Mac. Y'all need to have a pity party for me right now. Okay. So we've got it, Womack. We've got our cat, we've got our fish, we've got a class called animal that has both. Right? Okay. Does animal have has tail?
No, but the cat inside animal has a tail.
Which means from the caller, our program, I've got, if I created an instance, which we're going to get rid of this, so don't sweat this. So I'm going to say animal, A equals new animal. So now I can create an instance of an animal. And if you look at that, I've got a dot, and I've got my cat and my fish. But I still have to know which one it is. I have to know it's whether the cat or the fish if I'm trying to do something with it. So just imagine 100 animals, right? And this animal is holding on to that. That's okay. It's maybe a bit much. And I can't say animal.has tail. I got to go animal.cat has tail. So there's something called law of Demeter that says don't get more than two levels away from the root. So you don't ever want to say a.this. It's like something.this. Because now you've got assumptions being made one level away from where you were. So delegate to the animal and say, give me the cat's has tail if you're going to do that. So let me just show exactly what I mean. You'd create a method here, have tail. And this would say if cat is null, because the cat can be a null, right? Return false or something. Else return cat.
Okay, now over here in the program, you can say animal.does cat have tail. That's better than saying a.cat.has tail. Okay? Because you see, what we wouldn't have done in the program, like on the caller, we would have said if a is not null and a.cat is not null, then get it, right? This reads a whole lot better. Okay? And so never go 2 levels away. It's too much. Okay, so I'm going to get rid of that. Everybody see why we don't want to use animal as a class? We clear? Awesome hair guy, are we clear?
Yeah.
Okay.
So the whole point is not to
Look at
have.
this hair here. Sorry.
It's good. It's good. My hair was like that.
So the whole point is that you don't want to combine everything to a class because you get 2 levels away. You get
So you're
further. So
saying one
you'll probably have alphabet. So you get alphabet, then dot English, then dot west side of Texas,
Right.
and then dot this sound dot. You just get too far.
Yeah.
Right. So you just try. That's the reason why we don't do that. Is so that you don't have to have dot. You can
Yes.
just have one dot.
Yes.
Supposedly.
And,
Oh, okay.
And when you
Yeah, that's fine.
when you have a class, we didn't talk about this, but you want to name it appropriately. We spend a lot of time on naming. So there's been times where you guys might have had Steve Bannerman in classes. And he was my mentor in 2004. We would spend half a day or a day thinking of naming because we're about to start some big architectural thing. And naming is so incredibly important. If we're talking about an animal and we're looking at a class called animal, it should be an animal, right? But ours wasn't. I was actually just a container for animals. It wasn't an animal itself in this example. So I couldn't talk about it that way. We used to take a beanbag and I would throw it to him, he'd catch it, and we would run this scenario. Okay, we're going to create this big software, right? And I'd say, okay, I'm the employee. Here's my job code. And I'd throw it to Steve, and Steve would catch it. And he would throw it back and say, but I need you to give me the cost code because I don't know the overtime rules. And so in our minds, every noun that we say is a class. Every verb that we say is a method on one of those classes. By the end of an hour-long session, of throwing this stupid ball, and I'm not kidding, we did it because it was fun. It's a lot better than just sitting around talking about it. We had formed in our mind this story that we're about to tell when we sit down and start writing. So we're talking about like beginning the whiteboard, we're going to do a lot of them sitting down writing. True. So we use the ball checker, using the whiteboard. They do think your users are easy. Okay, we can't almost ask. Next step. We talked about it at dinner the other day. What is it?
God, you're making me test my memory now.
I know.
Oh.
It was 2 days ago. What do we have, finals coming up?
You actually.
Oh, that's right. That's right.
I've had to stay up till 5 a.m. at least those 2 days.
Oh gosh. What was it? We talked
Interfaces for.
As a
interfaces.
general term, like as a coding term,
Come on, Julio, using interfaces, we talked about that in Game Dev 2. Right, our manager's interface,
Oh,
or actually iGame manager interface.
yeah.
Everybody likes that. So you know how to C# because it's with an I. In Java, it's the opposite. In Java, they'll have animal as the interface, but they'll have cat impl. So it'll say the word cat, IMPL implementation. So in Java, and it's quick, and it's one of the following language conditions. Just that, we're able to pick what it was. Okay, so you've seen it and you forgot it. Shame on you. Shame on
Oh
you.
yeah. No.
All right, cool. So here's what we're gonna do. Let's create a new file, and let's call. Didn't I? Pull this picture. Wait, we got this.
Geez.
Don't mess this up. You got one count.
We got some pressure right here.
Yeah.
but it's going to be an interface, which is what
Maybe animal?
Perfect. I'm going to call it. This one.
Oh.
He threw the ball at you. Animal. Boom.
Yeah.
Okay.
Hey, fun fact, since we're doing interfaces, why does Java use impl for the tail end, the suffix of their class names, instead of an I at the beginning of their interface names? It's super pedantic, but it's a good reason.
Why Java?
Huh?
Why Java does it?
Yeah.
I haven't looked at Java in like 2 years.
That's okay, but just in general, why do you think? It's just a naming thing. Why not start out with an I?
There's a reason for it. What would be the reason for it?
because we want to describe it better.
No.
Is it, you think, to be different from C#? Or
Actually, Java was first.
okay.
Yeah. But maybe it's the .NET guys that were the problem. Normally
What
it is.
would it be? Poly, because is there like another use for the I in Java? No?
Not that I'm aware of. What's a noun that starts with the letter I? Give me a noun. Kind of like animal, but not animals. It's something that's a generic noun. Anybody think of anything?
That starts
Insect.
with the letter I?
Yeah. What'd you say?
Insect.
Okay. So we do I insect. Hey, come on in. What's up? Okay, so if we create this, what's weird about insect? I insect.
There's two I's. This is I.
Yeah.
It's just insect.
It's super irritating to look at.
Wait, so the whole reason why we don't do like I is because there's few names out there that start with the letter I, and so we get
There's actually way more than you can imagine. It's super frustrating. So I'm a .NET developer, and my interfaces have to start with an I, and the first word starts with an I. I've got I. It's super frustrating. So fun fact, I think Java got that one right. We got it wrong.
So if it has I, what do you say? Do you say I insect?
Yeah. Still irritating. It looks gross, especially when you're writing on a whiteboard. Are you writing LL or I? What is
Yeah.
that?
oh that was an issue.
Okay, who wants to take a stab at this? What are we going to put on the I animal?
Oh, what would you? Would you put like? Because this is what's supposed to interact with fish and cat, right? So would you do like an array or vector maybe just to contain both of them?
No, because remember, if we do that.
Oh, then you have the
that's
same
it.
issue. The same issue. Oh,
Okay.
because I don't know what an interface does.
Okay, good. Very good. All right, so what am I putting here?
I wasn't prepared for that question.
But it's simpler than you think it's going to be. It's usually the easy answer is the right one.
Is this?
Does this involve the T? So it'd be like animal parenthesis,
No, no generics.
no generics.
In fact, you're going to use generics later, but don't default to generics because it's far more complicated than just using interfaces.
Okay.
Would this be where you have that if statement then?
Nope, no conditionals.
No conditionals.
No conditionals. I really don't know. Template. I'm trying to remember my data structure class, and it's pain.
Can I buy a vowel?
No.
Oh. A bowl?
Told you it was easier than you thought.
I've never coded.
You're okay.
So
No, it's good. You're totally fine. Okay. So we're building out our template, okay, our interface. Okay, so every animal should roll up into iAnimal. So anything that you put on this interface needs to be applicable to any of its children. So don't start putting stuff like, has 4 tires. This is an animal. This is not a car. It's not an automobile. Doesn't go on here. So if you're going to start building some sort of a product-based website, you're going to sell animals and cars, you don't want to mix and match what you're putting on these interfaces. Don't put a square thing to a round hole. It's not going to work out for you. It's going to feel easy in the moment when you're developing because you're frustrated. It's late at night. You just need to get this project done because it's due the next day, blah, blah, blah. Don't do it. It's going to make your life miserable later. You will pay for it, I promise. So do it right the first time. Okay, so we all have our has tail, right? We good here? So now what do? What do I do to my helper method first? Let's focus on that. And then we'll get rid of these up here in a moment. What are we going to do with our helper method? Call the interface? What's that mean?
I haven't used interfaces before, so I'm not fully sure.
I think you're headed on the right track. What's the return type for our helper method?
Cat,
But what do we want to be able to return?
either cat or fish. Oh,
An animal.
So we return,
An animal.
So we return just a rule now because the only thing in the interface is has tail, or are we returning the animal itself?
What's the method say? What is the name of the method?
Animal?
The name of that method on line 21.
Oh,
Yeah, so we want to actually create an animal.
Perfect. And return an animal, right?
Yeah.
That's our goal. Okay. Is it going to work?
I hope so.
Not
It
yet.
doesn't look like it. But
We still have some plumbing to do.
There's some red lines here. Turn with that again.
How we doing? Anybody stuck? We good? I'm getting lots of deer in the headlights.
I'm trying to figure out like where this interface. It's really this interface. This is like new for me.
Yeah.
It was mentioned sometime, but this interface, like, I would have assumed earlier that you need to include that iAnimal thing, but
Where?
and the very top for your. Like,
but it's already part of the source folder.
So we've already imported that.
okay. But then
It's no?
is we want to return iAnimal. So instead of
And y'all can talk to each other too. You don't have to run all this through me.
if we return that method, like from iAnimal.
Not the method. There's no method on iAnimal.
Oh.
We just have a member variable, remember?
Yeah.
What do we think it means? Because we need to
Yeah, the interface.
Let me understand right now, like, create and
This wasn't a game that one.
return that. And then one. So that is some.
Actually, we didn't use it. A little bit of game that one.
It has.
Are you wondering if we change all of it, or just, is there a certain, this is a chart you're looking for an answer on right now? Or what?
So we changed the return type, right?
Yeah, we changed the return type.
Okay. So why do we have the red lines? And the red lines are compilation errors, right?
Well,
Because I don't
there's
really
no
know.
fish inside the
Yeah.
interface.
Good. Worded weird, but I think we're on the same page. So let's go to the fish. Is the fish an iAnimal?
No.
Okay.
Yeah.
There's the two relationships, has a and is a. Okay. So the fish is not an iAnimal?
No.
Are we sure? How about our cat? Is it an iAnimal? So we need to make it that way, don't we?
Okay.
So notice fish is currently red. Head over to fish. And in almost every language, you'll implement an interface, not inherit, but implement an interface this way.
Oh, this is okay.
Now you've got an is a relationship. So fish is now an animal.
You take the attributes from iAnimal and put it into fish without having to put it onto fish. So then you can do the same thing for cat, right?
But the actual, I'll show you in a second, you do have to have every attribute that's on iAnimal must be on fish.
Okay.
So the fish has to have a house.
Absolutely.
Okay.
Because if you're the runtime, okay, the application's running, and somebody says fish.hasTail, you got to be able to respond to that. You have to have that. Okay. We can mitigate how much duplication there is, and we could, if we have time, we'll do that at the end. But for now, I just want to show something real simple. Okay. So we've got the fish implements iAnimal. So now, if we go back to program, is the fish red or is it good?
It looks like it's good.
Okay. So now what do we need to do?
Do the same thing for cat.
Good. How we doing? All right. All right. So this get animal, what's the return type? Good. So what's my problem on this line, on line 16? We've got a compilation error here.
You're trying to convert an iAnimal into a cat.
Okay.
So how do we
Why can't I do that?
Because what if your animal is a fish?
Perfect. But watch, we can go the other way. So here's our generic animal. Okay? So imagine loading this integer from the database or from some external source and not just hard coding it in here. I suppose we can do that with command line args or something where you can pass in a 1 or a 2 or whatever and never have it hard coded inside of here. So let's ditch this. So in this case, we can have dog, we can have a cat, but notice on line 10 here, we just have like one object that we're dealing with. and we have no idea what it is. We don't care. Okay? I just want to say,
what is this going to resolve to here? When this program runs, okay, what's it going to resolve to? Hang on, let me do something to make it more real. Sorry. All right, so come on. All right. So what's going to print out on line 12?
It's gonna print out. What did it print out? Oh, it should print out false, right?
What's a 1?
A cat.
Okay. The cat has tail is
Default.
false.
False.
But you're not returning a cat.
But it's changing it, no? Because
The
oh.
animal returns the animal, but the only return statement you have in there is null.
That's good. You're rocking it.
you're doing very good. Okay. So what's going to print now?
False.
Okay, good. Because it's a 1, defaults to false to the constructor. Okay, all right. So just like that, we can just plug in a 2 here, and we're going to return what?
Or true.
True. Yeah, it's going to return the fish, print a true. Who's not getting this?
I understand. Okay, so what we've done so far is we made a iAnimal, we called it animal, right? And if I get animal 1, we're saying to either get animal is basically deciding what it is. So it's either a cat or a fish, right? And then with the console log, we're just outputting that method in iAnimal, right? We get it from iAnimal is either true or false, which default is false. And from the switch state or the if and else, we can change it to have it true.
Yeah.
Okay.
Okay, so normally what you'd see is this kind of behavior right here would go in a class called a factory, which earlier we were talking about big classes. Classes that are of type factory design pattern tend to be larger, but they look like this, where it's just newing up an instance and pre-configuring something real quick, giving it back. There's no core logic in them. It's just doing some pre-configuration. So cat.hasTail equals true. Yeah, cats have tails. Fish.hasTail equals true. But if we did a frog, its hasTail would be false. It still conforms to iAnimal, but the factory would pre-configure a frog to not have a tail, because, right, frogs don't have the tails. Okay? So imagine having, this is 2, and imagine having a system that you can just pre-configure all these different animal types. You can't have a class and all this stuff for every single type, right? You're going to have to create some interfaces, use some polymorphism to have some levels of indirection for how you do stuff and make it highly generic, right? So I promised to show if we had time, I think we do, how can we have less duplication? If we look at, you want almost zero code duplication, even if it's just what you're looking at. Like this is just a field, this has tail. So, you know, for me, it was tempting at the very beginning for me just to say, that's code duplication. Has tails in 2 different places. It's in fish, it's in cat. So how do we solve that problem? I guarantee y'all been through this.
And iAnimals give hasTail a default value?
It's an interface, so it doesn't live on its own. The iAnimal does not. So you can't have an iAnimal without having a concrete implementation that you can create an instance of.
Have a global variable.
No real globals in .NET, but even so, if you're to do that, you're still going to have a concrete implementation.
Function.
Say it again?
Function.
No function, because again, no matter what we do, at the end of the day, we do have to have a class. We've got to have an object of the type that's implementing that interface. It's a different technique that you guys have gone through in school, guaranteed. How do you reuse behavior? There's two different ways. Extension by something and extension by something else.
You overload something.
Okay, you're on the right track. How do you start getting overloading?
Make the same.
Did you mean overload or override? Do what?
I said overload.
Okay.
The overloaded function.
Not yet. Not overload.
But you did mention override, so that means you just write the same function name, but then you give it a new, like new ability.
But
Or you rewrite
okay,
what it is.
what do I need to do that? I'm missing a component here.
The base.
Okay, good.
Like where you grabbed it from.
Yeah.
That functionality.
Yeah.
I don't know how you would do that.
What do we call that? You've got your children, right? But
The parent.
the parent,
Or the parent type or parent class.
parent class. Okay, it's our abstract class. Okay, in this case in .NET, you can signify I want it to be abstract, and then nobody can create an instance of that on its own. It's kind of a cool trick. So what we're going to do is we're going to prefix it with the word abstract, and we're going to call it abstract animal. Hang on a second. What's a better name? So the animals we've used so far have tails. They have four legs. Oh, they have tails, not four legs. This may be not a good one to abstract because this is a weird example. What's the next thing we're going to do? Frog? So let's go with the abstract animal for now. We might change it a little bit. So a lot of the time you'll see either abstract as the prefix word, or you'll see the word base on the right-hand side. So animal base or abstract animal, those are the two primary ways people create these abstract classes, okay? And remember abstract, so there's two ways to extend behavior within a software system. So you can extend by inheritance, which we're about to do, and we're going to extend by composition is another way to do it. Have y'all done inheritance before? Where you have one class that inherits a parent class? So you just automatically, you've done it in Unity, right? Like if you're doing Unity, right, you're using those libraries.
You're using the Unity engine and
Yeah.
inherits another class.
Something.
And then finally, the script you write uses a model behavior.
There you go.
And then you can also use it for like movement. So if you have the same concept for movement, you can have a enemy movement and player movement, but still use the movement class.
Okay, yep.
Because they're still using movement, but
Yeah.
the player might move differently from the enemy.
Yeah.
So you can inherit that.
Okay.
That's all I know about it.
Okay, no, that's good. But it sounds like you've used it. If you're doing Unity, those behaviors that you're just using within Unity, it's not magic. It's coming from somewhere, right? It's in the Unity framework that you're using. So at some point, there's all the scaffolding that happens when you create your Unity project, and if you went and dug into the detail, you'd see lots of this kind of stuff, where one class is inheriting or implementing interfaces all over the place. And so if we look at abstract animal, the first thing I want to do is create it as a formal abstract class. So the idea is that I don't want people passing base abstract classes around. It's too confusing. And we've created interfaces that are super clean. So the interface looks really nice. There's no behavior. You can't add behavior to an interface. You can add tons of behavior to an abstract animal or to an abstract class. So as we're passing stuff around, a software system that's 2.7 million lines of source code, I'd rather pass an interface because they're really, really lightweight. You just look at it and you're like, oh, that's a definition. I can see what they're trying to do there. If you gave somebody an abstract class and said, hey, deal with this, they're like, where do I start? It's just huge, right? It's just too much to look at. They're heavy to pass around. So just remember, as you're writing software, you're likely going to write it once. You might edit it once or twice over the years, but that class is going to be read hundreds of times or thousands of times. So take care when you write for your reader. Right? Every time you're writing something, think about your reader. Okay, so just for me creating this abstract animal, I was like, wait, we should call it something else. I was tempted to spend 30 minutes with you guys coming up with a naming convention for the animals that we want, like the four-legged furry animals and then the ocean animals. We could have been here for a hot minute. Pizza would have disappeared. Okay, so what are we going to put at this abstract level? What do we know is going to be applicable to the animals that we have so far? Has tail. To 100% of the animals that we have so far. Okay, so how do I do that? Good. Okay, so it's that simple. Notice on the interface there's no access modifier. It didn't say public, private, protected, internal. It didn't have any of that stuff. I'll show you that in a moment. I forgot to mention that.
So we're going to do this pretty straightforward. Normally we wouldn't implement our abstract so directly from the interface. We would have one more level of indirection. That phrase, level of indirection, just get used to it. You're going to have it for the rest of your life if you're developing software. At every point, give yourself an opportunity to respond in mass. So normally what I would have done is had some behavior here at the abstract animal that's protected, not public. But it would, another property would leverage my private behavior before it responded back. And that would give me an opportunity to make some changes. I'm not making sense, so we'll come back to that if we have time. Okay, so has tail right here at the abstract level, we're going to leave it public. Okay? And so now, is everything an abstract animal yet? Why not? You shook your head no first, and you have to answer why it's not.
Because you've created this class, but you haven't connected it to anything.
Perfect. So how would we word that programmatically? So we implemented the interface. What do I need to do with this abstract class? I need to inherit this class. Okay, perfect. Okay, so we head over to the fish. I like to put my abstract classes first. So we're going to put it right before I implement. How many classes can fish inherit?
One, right? Because more? I thought it was one because I think that's like one of the limitations of C#, right? Is that you can only implement inherit one class.
That's good. So in C++, you can do multiple.
Yes.
And the really talented C++ developers do that like crazy to shoehorn things into what they want. So earlier we talked about has and is the two ways to extend behavior. You almost always want to have a has a relationship, which is extending by composition, not by inheritance. If you build this big inheritance tree, that's how you get things done. It's so incredibly complicated to add behavior. If you've got lots of inheritance down your object tree, if you want to plug something in, you're looking at it, you're like, where does it go? I've got like 9 levels of inheritance. Where do I plug in? And almost always we pick the wrong spot. And now something has a has tail, and then you look down the inheritance hierarchy, and it's a frog. You're like, dang, I didn't even realize I did that. It's too easy to make that mistake. So 99% of the time, you're going to want to extend by composition. When you're building a framework for the first time and you're about to hand something off to a bunch of developers, you're going to build out the inheritance structure early, but then it doesn't get modified much after that. So you'll use the inheritance at the very beginning. If you're writing a framework that a lot of people are going to use in mass, you'll use inheritance. If you're conforming to something that somebody else has written, you have lots of extension by composition, which is what we're going to focus on. Okay, so we've got it on one. So it's an abstract animal. What do you think this green squiggly is? Have you already cheated and looked on the house computer? A little bit. I see equal Mac. So what is it? What's it saying?
It's saying that it already has it. So if you want to use this variable, you need to change it a little.
Okay.
Because abstract animal already has the has tail function that you'll use.
Okay. That's good. So what should we do? Should we create a new property here on fish called something else? I don't really know what to do with the green squiggly.
I think what you can do is like overwrite or overwrite, right?
Okay. What do you want to change about has tail for the fish?
Can you set it to true by default?
You could. Do you need that in the property or the constructor?
Should we do this here? What's your name again?
AJ.
AJ. AJ, what should we do here? Should we set has tail to true here in the fish? Where does our cat have a tail?
Well, wouldn't this only be changing it for the fish?
Yeah.
So it wouldn't be affecting the cat at all.
Correct.
And I don't know of any fish that doesn't have a tail, so.
That's right. Okay, so we set it to true. We still got a green squiggly. We added something, but haven't solved our weirdness here. What do I need to do?
Get rid of that public.
Get rid of what?
The public.
Just this word?
No, all of them.
Okay, good. So get rid of the member variable. The property goes away. It's gone.
Oh, then that means we're stuck at our.
It's an inherent rule, so it should be fine.
Remember, Ignacio, a fish is an abstract animal.
Yeah.
It inherited everything that an abstract animal is. It inherited it.
But doesn't need it whatsoever.
You can't differentiate them. If you're on a client of this and you're just using a fish, it's not apparent to you where it came from. It's going to look and feel like it came straight from the fish.
Yeah. Okay.
Okay? What's weird, and I don't know if you guys are weirded out by this, is we're implementing iAnimal here on fish. But statically looking here, I don't have the member variable here. I don't have the property defined on fish. It seems to me like the compiler would complain. And it used to a long time ago.
Is that why you put abstract animal first? Or does that not even matter?
Doesn't matter. The only reason I use abstract is because I don't want anyone to say abstract animal equals new abstract animal. I don't want somebody to create an instance of that. So by putting that abstract keyword in there, I completely prevent that from happening. And you absolutely want to do that. Take the extra mile and do that. What will happen if you don't do it is instead of people using iAnimal like you intended, everyone's just going to use abstract animal. And you look throughout a system of 2 million lines of source code, you're going to see abstract animal everywhere, and you're going to go, oh my gosh, why didn't they use iAnimal? Because here's something cool that we can do. I can create something called
Has big ears. We can get rid of this. We don't have to keep this. I can create something called has big ears here. It's not on iAnimal. I never intended for somebody to know about it. It's some part of my core implementation of what I do with animals at the abstract level. But I don't want clients setting whether or not a fox has big ears or not. I'm going to control that myself. Okay? So we define a member variable at abstract animal that if it's not on the interface, if I go over to my program, I've got an iAnimal. Will I see has big ears?
No.
No. Because it's not on the interface.
Oh.
Encapsulation, it's one of your 4. Okay?
So generally, clients will have access to the interfaces in just the end of
For
generic.
everything.
Okay.
For everything. So these words won't make a whole lot of sense today, but they will at some point. Everything within our domain and service layer gets exposed through interfaces. Nobody ever has concrete implementations of what we do. Okay? It's super important to go that direction. You can even use dependency injection. Have you guys done like Spring, anything like, nothing like that? Okay. That's pretty normal not to do. You won't do it for quite some time, so don't sweat that.
Okay.
Woo. The muscles. Okay, so we don't have has big ears in this thing, which is good, right? So we've done a couple of things. We've created a couple classes. They didn't really know much about each other. They didn't conform to any common structure, but we created the template, right, AJ? Created the template, which is our interface. Now both classes implement that interface so they're both now I-animal. We're headed down the right path to have, we've already done some polymorphism, but we're headed on the right path of having a software system that scales really nicely. So then we noticed, we did fish and cat, they both look the same. So we created this abstract animal with the member variables at the top parent level, okay? Because we know that all these animals are going to need to respond to has tail. So what do we need to do now? There's something else we need to take care of, clean up. We did it to fish.
You do it to cat.
Do it to the cat. All right.
Oh no.
So do you need to inherit the abstract class?
Very good. How'd you know that?
Because you did it to fish.
Yeah, but he saw the red squigglies and brought him great anger.
Well, yeah, I guess just because you did it to fish, I assumed that we would do it to cat as well.
What's cat missing right now, Matthew? What is it?
I mean, let's see.
As does.
It's missing the inheritance.
It's an inheritance, but we could actually do this without the inheritance. I could add that property back into here, and I can still implement I-animal. I can use it from the program and not inherit abstract animal.
But if you do that, then you need to set your default tail value, right? Or are we just letting it default to false for cats?
It's implicit right now, so the runtime is doing it. AJ had us set the fish one explicitly, but that's irrelevant to this conversation. Yeah. What's this class missing? How many Matthews do we have in here? Is it
Just two.
just two? Okay. For now.
For now.
For now. This is a class cat. Do we need to get it?
Get what?
The
You can cheat and hover. Beard Matthew already said it. I have to differentiate, I'm not sure. That works, right?
Yeah.
Okay, so what are we missing, Ignacio? Do you see it yet? Have you visualized it?
animal is not about your face. I lost it. I don't yet.
Leo, can you help him?
Maybe the abstract animal.
Okay. That would get us there. Why would we inherit abstract animal on this cat? We do it for a reason. What is the reason?
Because they both share all the same properties. Like they both have a tail.
What does? You said they.
That cat and fish.
The cat.
They can put itself, which is good. But the compiler's telling us about easy way to fix problem. What we have. Remember, right? Immediately I put this way. I'll count it. We're dead. Not saying.
Is it because that member variable is in the abstract animal?
Good. So I was trying to drive out. I want to make sure you're connecting these dots. So if we're the abstract animal, inherit the abstract animal, this squiggly goes away. I know we just went through it. Repetition's key. It was still a little bit confusing because this time we took a different route to it. Confused you a little bit. It's good.
Okay.
Okay. So going back. You can do things with this. Okay, so something else to show quickly. Now you are smelling pizza, you're ready. So, in a larger software system, you have multiple layers. It's called a layered architecture. So not just technical architecture, but design architecture within the software itself. You'll have on the back end side of it, you'll have this, what we call the front of the back end, which is the web service layer. That's where all the public endpoints come in. So HTTP, www, whatever, and there's some kind of have you guys used Postman or curl? Have y'all ever done anything like that before? You just make these JSON requests or public requests up to a web server. Those are called public endpoints, or just endpoints if they're private, but those are endpoints. That's our web service boundary, okay? And if you're writing back-end development, that top layer, it's a very, very thin layer of web services. It's broad, but it's thin. You shouldn't have much behavior at all in those. One step down is your presentation logic. So I know you guys have heard of MVC. Back in the 90s, early 2000s, there was something called MVP, which is where MVC came from. So it's Model View Presenter, and it was really about encapsulating the view, what you see in the user interface, and taking the logic behind that and moving it away from the view. So if I wanted to have like a WinForms application, but then also write a web application to do the same sort of thing, I don't have to duplicate that logic in both different technologies, right? So if you push behavior down, the further down it goes, the more reusable it is. So we take behavior in a web service layer, push it down to what we call the presentation logic, that's that middle layer, becomes highly reusable. If you keep pushing down, you end up with what's called the business logic, the very bottom layer of a layered architecture. Inside of that, that's where the core is. If I'm going to read and write from the database, it's all going to happen from the business logic. In fact, the presentation logic doesn't even have references. Now, if we look at this guy, it's got all these dependencies. So this one's .NET Core, so they're very, very lightweight. Normally in a .NET application, if it's a full .NET app, you start off with like 8 or 10 default references. These are libraries like in Unity, all that movement, all the stuff that just comes for free when you create the new project, all that helper behavior just comes for free. And so kind of what I'm driving to is you've got the top layers, the web services, it's very, very thin, it's very generic, it's just very high level for a user. So think user, what are they thinking about? You're going to see that correlate over to web services. If you go a step down, this is where all the logic happens to coordinate with lots of different business logic classes to gather information. So if you're writing a web service for ASU and you wanted to say get students, okay, it's just a web service method called get students, all that's not just in one table in the database, right? Y'all taken any sort of database classes with tables and stuff like that? Not a whole lot?
I've used it for like a light one, like Qt Lite for Python.
Yeah.
But like as in like super detailed, no.
Okay. But I heard you have done structs. Y'all just did structs. So structs is about building this data model. You're not going to have all this stuff in one spot. Like that won't make sense. So it's all distributed across many tables, normally thousands of tables. And each table is pretty small. Just like for classes, we don't want one huge class. Same thing for the table. We don't want one huge table. We want to separate things into logical matters. So typically what you end up with is at that bottom layer, your what we call domain, which is your vocabulary model, is protected by interfaces. So you can have an iAnimal that lives in your domain with just a getter. And what's cool is from the program, sort of the client-facing part of this, the people that are using the system that you built, notice I can't set has tail. It gives me a white red squiggly. It's read-only. So from the interface perspective, you can actually perform encapsulation at the same time you're doing some polymorphism by just taking the setter away from the client. Now they can't set this. This is super helpful if you're wanting to control how people define the number that gets assigned to an animal. If you're wanting to make sure on the business logic side that if a cat comes through, somebody's trying to create a cat, you're going to control that. You're going to set it down in the business logic, and I don't want somebody setting has tail one way or the other. You can control that and control whether has tail is true or false based on the animal type or some species of animal or something like that. So just wanted to show that you guys, I don't know if you're seeing it yet, but you've gone through polymorphism at this point. We started off by just creating new instances of every object type, and we backed that out. We're like, no, we don't have to do that. Imagine this thing going to a database to load an animal type from the database and coming back and just providing that number here. So, a good takeaway is if y'all, I know you have finals, if you're wanting to play with this, check the pass this through as a command line argument. Have y'all done command line arguments in your main, being passed to your main function and doing stuff with it, right? Y'all all done that leap year thing. Everybody has to write a passage. You can't get a CS degree without doing leap year thing.
Leap year thing?
You're telling me Dr. Modal's not still here? Really? Just kidding.
He's the
trying to remember which slide it was.
I think it's, if I remember, it's one of the labs and data structures.
Is it the one where you just have to divide like 4,000?
Yeah,
Like you just
it's
mod
pretty
by
much
4,
that.
a
You
bunch of
divide
mods.
Oh, you have that too in CS1, the leap year. I remember that because 5 people that night doing leap years.
I remember doing it.
You guys gotta get it together. Ridiculous.
There's a lot of gaps. There's a lot of gaps right now. Animal type. Oh, it's.
I haven't done it manually because I have help with classes.
Go for it.
32.
Alright, so imagine this. I'm gonna put the setter back. That's just for show. So notice on the program now, there's no hard-coded numbers. Whatever you pass into the main is what it's gonna do. There's actually hard-coded here. Okay, so we're not, from the client perspective, we're not defining the number. Okay, the number is all defined. Just remember, pretend this is a database call, goes out to the database, gets an animal of some number, and it comes back, and now you have the animal. So if you don't look at that, you look here, this is what you end up with. In your client, the client side of this business logic, or, however you want to look at it, you're making a call saying, give me the animal, all I've got is the number. And it comes back. Just imagine if you, as the client developer, would have had to say, look, if the animal type equal 1, it's a cat. Else, if the animal type equal 2, it's a fish. Now you've got 1,000 different animal types. Can you imagine how many different places you'd have that conditional? It'd be everywhere throughout your software, right? So you don't want that. You want to delegate down, create some polymorphism, and now everybody can work strictly based on an eye animal. As long as you have an eye animal, you can operate just like if it was a cat or a fish. A better kind of analogy, and normally the one I do, but this one took live, is a method called move, because that resonates with people a little bit better. A fish definitely moves differently than a cat does. And so when you implement, and this is where we talked about this Ignacio the other day, they move differently.
Yeah.
Okay, so now if I go to the fish and the cat, I need to move these things. Would I put this, and we'll wrap with this. Would I put move at the abstract level?
Because they move differently.
They move differently, so what do I need to do?
Would you make a new abstract?
I could make a new abstract.
And just call it like, instead of, you still call it abstract animal.
Why not just put the move in the separate classes?
Good. That's the simplest thing right now, isn't it? It's the simplest thing that would work for the classes and types that we have today. So you could just say move, and I guess the fish would swim and the cat would still flick the legs.
Little waddle.
That's it,
Okay.
right?
So you would move. So if you had to change because both, like you said, both cat and fish move, right? To define where it's different, you would do it in their own classes.
Yeah.
Okay.
Otherwise, your abstract class needs to consider the animal type, and it will have a conditional right there, which is a thing that you have to maintain. And I guarantee what's going to happen is you guys are going to get in the mode where you're like, oh, if it's an animal type of less than 10, it happens this way. Anything 10 to 20 happens this way. Okay? We've all been there. We've all done that. And in the end, you're like, oh, man, this is awesome. I don't have to add new stuff every time. As long as it's less than 10, and you're like, well, I just reached 10 of those. And then you look at your conditionals and you realize you've got if less than 10 and else if this number is less than equal to this number and greater than equal to this number, you're like, oh gosh, I'm going to make a mistake.
So
It's so hard to work with.
So all this helps basically removing having to put those conditionals.
Absolutely.
So we don't, because conditionals are where mistakes happen.
Absolutely.
Okay.
I have seen 20-year developers with the simplest conditional right in front of them and goof it up 9 times out of 10. So if you can design yourself out of complexity, do it. I'll tell that 1,000 times. So if you can go the extra mile and create a class, if you look at this cat, doesn't this look retarded? I have a class right now, I can't say that, sorry. If I have a cat right here, I have a class with no code in it.
That looks.
But you do.
Do what?
But you do.
Right,
Because you have a-
sort of.
You have a cat.
Right.
And cat is connected to an abstract animal and an interface for animals.
Right. But notice, there's nothing in here. Between the braces, it's empty.
Because it doesn't need anything.
Right.
Okay.
So what's up, AJ?
Okay, so I was wondering, so I know that it's obviously a class of cat, but would you consider that class to be like a type of abstract animal? If that makes sense.
Yeah, absolutely. It is a abstract animal. There's has and isn't, and it is a. Yeah. It's a more finite, so I call it a child class of abstract animal, and abstract animals of parent class. And you want to talk about it. Again, I joked with you early on about no pronouns. Don't use pronouns. Everybody in the room is going to make an assumption about what you're saying, and we're all going to be on a different page. So when you're talking about stuff, make sure that you're super clear, using the right nouns, and write on the whiteboard. It's even better. Take your time at the very beginning.
Okay.
Yeah, an empty class seems weird. One of the hardest things I've seen when I interview fresh grads is just, I have this sample problem that I walk people through during the interview process, which you can't do because hopefully I can do it with you guys someday. The first thing is I'll say, okay, so create a class. Just on the whiteboard. We don't even have a computer. I'm old school. I don't want a computer. You guys made me use this. You made me do it. We just go on the whiteboard and they have to whiteboard it. And I don't care if it's pseudocode, it doesn't matter. But I just want to see an object graph or a diagram, or they can do the source code on the whiteboard. I've had it every different way. Probably interviewed 700 people, probably more than that, with that exact same problem. And I've had one person ever get it right. She was incredible. She still works at Time Plug Plus. But it's something like this, where you end up with this highly complex issue. It's actually a really simple issue with a highly complicated solution. If, else, if. They end up with integers with the ranges, stuff like that, or a list of numbers, and if it's in the list, then it's a done. And we end up getting to the end of it, and we say, there's no conditionals. So you've reached there's 4 stages to this problem. Everybody goes through 1 through 3, usually takes about 30 minutes, it takes an hour and a half to get through this problem. It takes about 30 minutes, and they get to the 4th one, and that's where it takes another 20 minutes, and they're like, okay, I give up. And I'm normally helping them, talking them through it, right? It's still so complicated. When you start saying, create a class, and create some inheritance and some object structure, people are immediately like, they're scared to fail. They don't even want to create a class because they're like, I'm just going to judge them for creating the wrong class. Create the wrong class. Just do it, because it's going to help you get to where you're headed. So, that's a big takeaway, is just don't be afraid to create classes, even if they're empty, even if you feel like it's not the right class to create. Do it and iterate on it. It's not like it's final. You're not going to create software and not change it. The best software is software that never changes, right? It's just perfectly written.
Does not exist.
Doesn't exist, and let's better hope not, because the worst software is the software that never changes, because nobody uses it. So if you've created some software and you're like, yeah, no, I'm never going to have to change it, it's made it perfect. No one's using your software, I promise. So good luck selling that.
All right.
Okay, what questions, comments, concerns? Julio's like, oh my god.
Okay, so just so I get this right, so you're basically what we did, right? And by the way, I use basically a lot. Apparently, people have called me out, my siblings, but basically on the main program, we've made a way to define, use one animal, right? And then from animal, we can have a function that tells it what it should be, right? So, I don't know. Okay.
That's good. No, that was good.
So, because from get animal, right, we can be like, we want a cat, right? Which we give a 1, which then from get animal, it then does the controller part from, I would say MVC, right? The controller part, it controls it and be like, okay, well, we need, if it's a 1, then, or a 2, then we create a new fish. which to give it like the methods that all animals of a certain category has, like if it has a tail, we then call the interface.
You reference the interface.
You reference the interface, and then the abstract. See, that's the part where I don't understand. I still kind of don't understand the interface and the abstract purposes. The interface is what the client sees, but the abstract is what is referenced in the interface.
Yeah, because your client. Remember, this is the client.
Yes.
There's no such thing here as an abstract animal. They don't see it.
Yeah, they
Look
don't
at
see
that code. It's not there. You also don't see dog. I mean, cat or fish. You don't see it. It doesn't exist here.
Mm-hmm.
So you can't get to abstract. Who's the abstract for?
It's for the interface, right?
It's for the developer.
It's for the back-end developer that's creating this overall design. They're going to leverage that abstract class. They're going to get a lot of purchase out of that thing. They don't have to put has tail in every single class, every child class. They did it one time, they're done. So they get a lot of purchase out of it, but you don't get confused by it. So Ignacio, if we had abstract animal in here, which you could use, we could call this abstract animal.
But then
You have to use something called savecast to box it in. That can result in null. So don't do casting. Don't do casting. Don't cast.
I got you.
Very key concept. Don't
So
do this.
This is
So
what
what
called
I'm
a
hearing you
savecast.
say is don't cast.
Don't do that. Yeah, you're gonna not do that. So that was it's called a safe cast. This is an unsafe cast. So the first one would result in null if the data type doesn't align. This one will throw an exception.
Okay.
Remember the program that crashes? That's what would happen if you're not catching. So don't cast. Don't use abstract animal. And remember, these abstract animal, it's complicated. Like if I'm looking at abstract animal, there could be a lot going on. There could be 800 lines of code in there with implementation, helper methods, stuff like that. But if I look at the animal, look how simplistic that is. Without these ridiculous things, this would be a two-liner. And it would just look super simple. If you go over the abstract animal, with a bit more, you can have a ton. So it has big ears. Doesn't even need, it's not applicable anywhere. So if I'm passing around the abstract animal, I'm already telling the client too much. They're already seeing things that they don't care about. Okay. They can't do anything that has big ears. It's not part of our program. So always pass around that interface for simplicity, brevity, clarity, just the ability to react, the ability for your client classes not to really understand your object structure and your inheritance hierarchy. Definitely don't want them aware of that. It's going to make your life heck. What they're going to do is go plug into your code over there and like hook into your inheritance hierarchy and add some stuff that they wanted to add.
And then
So-
everything breaks.
Yeah, it could break. Just get muddy. You guys have heard of spaghetti code. I think we talked about it the other day.
Yes.
Very quickly becomes spaghetti code. Now no one wants to maintain it. You start pointing fingers at each other, and it's nobody's fault. You don't just. I wrote this. I don't own this. We own it as a team. So it's not like God. I've had people like that. Like, God, don't touch my stuff. I'm like, what? Are you kidding me? And it can go the other way. People are like, oh, no, that person wrote that. I'm not touching it. There's people on my team where people won't touch their code because they're skilled developers and they're like, oh, no, I won't touch Jacob's code. Yeah, touch it. It's fine. Just have them review it or pair up, work together. So,
Okay.
what else?
I just love how we just all for just to say that a cat and a fish has a tail.
Yeah.
We had to come up with. We had to make a factory for
Yeah.
iAnimal and just animal in general. Oh God.
Yeah.
So this is possible with every object-oriented programming language.
Yeah, it started in Smalltalk and then emerged from there. So I don't know of an object-oriented language that doesn't have it. Pi is a little bit unnatural to do it with.
Oh.
This is a scripting language, but it's kind of somewhere in the middle. But yeah, every managed object-oriented language that I know of does this.
Okay.
All right, question.
Yeah.
So I'm gonna make the assumption you probably didn't master this overnight. So how long did it take you to get to this point
Yeah.
where it's just a second language?
Natural. A long time, honestly. So So, have y'all met Steve Bannerman? I don't know if y'all probably know him, but does anybody else know him? He's super dry, super dry. And so
Drier than modal?
Oh gosh.
Drier than
Oh.
modal?
I don't know about that.
Okay. Very similar then. I now I understand this person.
But they're different people. So Steve, like, for me, it was like he was my mentor. You know, I wasn't supposed to be a developer at Time++. I started in 2004. I was supposed to be like the operations route. We had this plan built to be like a COO type route, like an operations person. And George said, we don't have an engineer, the founder of Time++ said, we don't have an engineering team, we've got to build one. I said, okay, what are you going to do? He said, do you want to learn how to write software? I said, I'll do whatever you want me to do. I don't need to be a COO, I don't need any special time in the world, I just want to be able to contribute to this, what we're doing, and kind of my goal in life is to make others better around me. And so it didn't matter. Like, I get my fulfillment out of that. And so my brother, I told you all about Marshall. Thankfully, he knew one language, so he helped me. Still knows that one language. That was in .NET 1.1 back in 2004. And we hired Steve. Steve came in. He was a PhD student from Oxford University. He lived in Canada, from Canada, moved to New York, moved to all these places. And Jason Burnett runs the FCA he was running it here in Angelo, and then now he runs it for the state of Florida, which is pretty cool. But George knew Jason Burnett because they were hockey buddies or something. And then Steve Bannerman came in from Canada. He's Canadian, played hockey. So now they're all like, talking about this stuff. And Steve's like, and Jason said, I can introduce you to a software guy. Before you know it, Steve's at the office. And so Steve works 12 hours a day.
Jeez.
He gets there at like 9, which means his 12 hours is like midnight, get back home, rides his bike to work every day. And he was super dry, super frank. There was no beat around the bush. So he'd be mentoring, and for 2 years I was paired up with him in his office. I didn't really write code, I just was paired learning from him. And I was a domain expert with our product, he was not. So it took the two of us to develop this enterprise product. So I had the requirements in my head, and he had the ability to do his thing, which was incredible to watch him. So I spent 2 years just doing that, and I bet it took 4 years for the two of us together to really get to where it's just natural language. But I didn't really get comfortable like this. Like I was telling Ignacio and Womack, like, if you guys wanted to change the topic right when I walked in, it wouldn't matter. Because it's a second language. After you've been doing it for a long time, it's a second language. So don't feel intimidated if you don't know it and you're like, what's going on? Don't feel scared to ask questions. People that know it want to tell you. It's like he's saying, it took a long time to learn it, so it's like, I'd love to share that with somebody else. I always tell my teams when I'm training, I'm like, I don't want you to make the same mistakes I did. Like, surely my screw-ups accounted for something, and I can teach you so you don't have to go through the same thing I did. So it took a long time, for sure. But read the literature. I was telling Womack.
Design Patterns?
Today, Design Patterns by the Gang of Four is probably the most valuable design book you'll ever read. It's very, very good, and it doesn't even change often.
Can you write some of those books on the board?
Yeah.
So I can take a picture of them later?
Yeah, I'll just write them right here.
Yeah.
So actually, I'll just
Put them in a comment and you edit it. There you go.
There you go.
Okay. Also, what is that book you said by Uncle Bob?
Think that
Is that?
Yeah. We will put it on Discord just for you too.
he also has one called Clean Architecture. I would encourage you can read it, but don't get too invested because architecture is a little bit more difficult. Take that later in your career because you'll get frustrated
Okay.
with the trade-offs. It's hard to make trade-offs when you're younger. We tend to make really bad trade-offs when we're young in our careers, and architecture typically takes 15 years before you
Invested because architecture is a little bit more difficult. Take that later in your career because you'll get frustrated with the trade-offs. It's hard to make trade-offs when you're younger. We tend to make really bad trade-offs when we're young in our careers, and architecture typically takes 15 years before you become an architect of some sort. Not trying to discourage you from getting into it, but don't feel bad if you read it and you're like, this seems stupid. That was super simple. Like, why was that such a big, why do we have to put that in a book? I promise you, it's valuable, but you don't really appreciate it until you've made a ton of mistakes. Or been on a team where somebody else architected software for you, and then you had to live with that. And you're like, God, I wish I had a say in that at the beginning. So the other one is, and this one's big. Pragmatic Programmer. That's I forgot No, I forgot the guy, but it's really good. It's very good. No, I gotta find it. I know. Andrew Hunt and Dave Thomas. So Dave Thomas and Andrew Hunt are just two artists. Authors that are really good.
I think I actually told you before, by the way.
Yeah.
I thought that was like.
The one that like Steve would have had you read is something called Code Complete. About this thick. Required everybody to read it when they got there. It'd take 3 months to read. It is the driest book on earth. Doesn't provide a lot of value. If you'll stay engaged now and get some fundamentals under your belt, like this kind of stuff, creating classes, short class, just the fundamentals of a lot of what we talked about today, you don't need to read Code Complete. But if you're not going to invest much time outside of school and you're not going to go do stuff on your own, I'd read it. It's dry and painful, but I'd read it. But you're given the tools here in school to tell you to go figure stuff out, right? But they've got 50 minutes 2 or 3 times a week, and they can't teach you everything. So you got to take it upon yourself to go do it. Those are the main books I think I'd recommend for software development. There's other things like how to work on a team, things like that. And I would encourage those. There's a guy named, I'll butcher his last name, Pat Lencioni. Just about teamwork and team building, working within a business. Those are super important. A really good Christian guy that teaches a lot of what he does based on his faith and the ability to treat people the right way, treat them how you'd want to be treated. But he is probably the world leader in building healthy organizations. He's incredible. So I'd have a read of that because, and there's a podcast called At the Table. If you'd rather do a podcast, it's actually really good. Check out his podcast. They're like 15 minutes long each episode. There's about 115. But do it because you're going to go join an organization. You want to know if it's a healthy organization or if it's just you. Who here has worked professionally? Or who here has had a job? Had a job? Hey, that's pretty good. That's good. Anybody had like a professional job? What'd you do?
I was a welder.
Okay, good. What kind of welder? Were you MIG?
Stick, MIG, and
Oh, thank goodness. I thought you were going to say just MIG. I was like, you weren't a welder. Cute. That's awesome. You could teach us something. Anyway, what Pat Lencioni will teach you is like, are you joining a healthy organization? It's going to be important for you to know if it's just you or if it really is a healthy or unhealthy organization that you're joining. So it's just good to know. So that's a good one. Those are the main ones, and I check them out. Start with Pragmatic Programmer. It's the first one. It's the day in the life. So when you walk into your job, like what's expected, like what should you do when you walk in the door? Pragmatic Programmer lays it out in a very pragmatic way. I know, it's crazy.